record. We said we have some additional characteristics of replacement analysis, such as the sunk cost. Simply, the sunk cost is a value you cannot add to your cost analysis. Let's give a small example. You like bicycles, or you like phones, or something like this, and you were going to buy a bicycle, and you find it for some seller. He was selling it at 100 US dollar. Then you were moving, you give him like $20 just to book. You don't have the $100, but you want to book or reserve this bike. So you give him $20, and he told you you cannot reimburse this money again. You cannot refund this money if you don't like to get the bike. So you said, okay, no problem. I love the bicycle, and I go to home. I back home. I give my the remaining $80 and back to you. You moved forward, and you find the same bicycle. You found the same bicycle. It's almost identical, and you find the second seller sells it at $70. So now you have two options. The first option is $100. You need to bring back $80 to buy the new bicycle, or to go to the second seller and you buy it at $70. Okay, you cannot refund the reserving money. Okay, so you have two options. The first option is to buy the bike from the second seller at $70, or to bring back $80 to the first seller and take this bicycle. In a benefit cost, you say I can save $10 if I bought from the second seller. Why? Because he already sells it $10 less than the remaining amount I need for the first seller. The $20 you already paid for the first dollar are sunk cost. You don't consider them. I just consider 70, okay, against 80, not against 100. I say I pay 70 to buy the bicycle at all, and I pay 80 if I went to the first seller. I already gave him, yes, $20, but I cannot refund it. So if I went back to him and said, please give me the $20, you cannot. So you compare, you just forget the $20, and these $20 are sunk cost. Okay? So you don't back to the first seller and give him the $80. You think again and you say, okay, I just bring only $70 and buy the bicycle from the second seller. So the $20 now are not engaged in our comparison. Okay, if we don't engage the cost in the comparison, we consider it sunk cost. Okay, the second terminology, or the second characteristic of our replacement analysis, is non-owner's viewpoint, and this is a really good characteristic of the replacement analysis. Non-owner's viewpoint means you are just a consultant. You does not have the old asset, or you does not sell the new asset or the challenger. So you perform without any bias. You are unbiased. So you just perform the analysis regardless of the value of the asset or the value of the replacement to you, because it doesn't matter to you. Okay? A new terminology is the economic service life. This is the basic of the first point, or the basic of the replacement analysis. If you need to understand or to learn the replacement analysis, you need to compare between the economic service life for each alternative, whether it's a challenger or defender. So the economic service life is a number of years at which equivalent uniform worth of cost is minimum. Usually, we do the replacement analysis based on the cost of the two machines, the annual cost, the total annual cost. I mean the annual worth, not the total annual cost, because we have annual operating cost, we have total annual worth costs. We gather everything in the challenger and the defender to estimate the annual worth. To estimate the annual worth. This is the annual worth for the overall challenger and defender. If you see, we have cost on the y-axis and the life for x-axis. When you buy the machine, the capital recovery cost decreases by the increase of the service life, while the annual worth for the operation, this is annual operating costs. These are the annual operating costs. Okay? The annual operating cost increases by the increase of the service life. Okay? Between them, they intersect. And the sum of these two, capital recovery and the annual worth, makes the total annual worth of costs for any defender or a challenger. It decreases, sorry, until a certain level, then it increases. What do we need? We need to estimate the economic service life, which gives the lowest annual worth costs. The lowest annual worth cost. Okay, so the economic service life gives the lowest annual worth cost for the challenger and the defender. Okay, so how do we estimate the economic service life? We estimate it through this equation. The total annual worth, if you remember, is still the same. You remember the annual worth analysis. It is the capital recovery, which includes the present and the salvage value transferred to annual payments, and the annual operating cost. Okay? It is negative here because they are costs. We are talking about costs. That's why it is negative. Okay? We have two different capital recoveries. Okay? Two different capital recoveries. The capital recovery is decreasing, okay, with each year of ownership. We call it decreasing cost of capital recovery. And we said it is the sum of principal or initial cost plus the salvage value. Both are transformed or transferred to annual value, A given F because it's salvage value, and A given P because it's initial cost at 0. There are another terminology is called increasing cost of capital recovery. Okay, because the annual cost or annual operating cost estimates usually increasing over the years. We said, if you remember, this one, this is increasing. Okay, this is increasing because it's increasing. Okay, the annual worth increases. The annual worth of operating cost increases. That's why the overall increasing capital recovery is also increasing. Okay, so the capital recovery is also increasing. The total annual worth for over years, over K years. Let's discuss this. Usually we have a project. I'm sorry, I cannot draw by the computer bad. A project with initial cost, which is B. Let's make it B. And annual operating cost, sometimes they are random. They don't have to be equally. Okay, so this annual operating cost And by the end of the nth year, the salvage value. In replacement analysis, we have different terminologies. We have different analysis. Why? Because every year, the market value of the machine changes. And if I want to replace the machine after K years, I will sell the machine at SK. So its salvage value now, it is not the S at the nth year, but it will be the market value of the machine after K years. After K years. So if I want to estimate the annual worth upon the replacement on the kth year, I use this function or this formula, which is simply the present and the salvage value. And we said the salvage value here is the market value. The market value. I'll tell you how we estimate the market value. Okay? Or at least how we consider the market value. Okay? And these all are the annual analysis of the machine. This is the annual worth or the annual operating cost of the machine. If you see this, it is, as I said, we cannot consider it directly A,